Right, let's have a look at this question that was sent by one of my learners once again. All right, please remember to send your questions to my personal email or to our WhatsApp number over here. So let's have a look at this question. We are given that 4 to the power sine x is equal to 6, while 6 to the power cos x is equal to 8, and 8 is equal to 32 to the power 1 minus 2 sine squared x. Now we are asked to determine the value of tan 2x. All right. Now what I have done here is I have went ahead and tried to establish the connectors between the equations. And I've taken this one and called it equation 1, and the second one called it equation 2, the third one equation 3. Now I have established the connectors between equation 1 and equation 2, and the connectors between equation 2 and equation 3. Alright, after doing that, this is what we need to do. Because I see that 6 is the connector between equation 1 and equation 2, what I am going to do then is take 6. In the place of 6 in equation 2, I am going to plug in 4 to the power sine x. Let's do that. 4 to the power sine x. To the power what? Raised to the power cos x. Remember, when we raise to another exponent, we multiply the exponents. This is what I've done. What is that equal to? That's equal to 8. Right. Here, the connector between equation 2 and equation 3 is what? Is 8. That means in place of 8, I can plug in what? I can plug in this value over there. But what is this value? We have just said that this 6 to the power cos x is what? Is 4 to the power sine x times cos x. Alright, so what we then do is rewrite this 4 to the power sine x times cos x is equal to, oh my god, what was that? Is equal to 32 to the power 1 minus 2 sine x, sine squared x, right? So let's write that. 32 to the power 1 minus 2 sine squared x. Right. Now what are we dealing with here? From this, it's clear that we are dealing with what? With exponential equations. What do we do when we have exponents? We apply the laws of exponents. Let's apply the laws of exponent and see what we get. All right. Remember that to solve the exponential equations, you need to have either the exponents equal to each other or the bases equal to each other. Right. So when we look at these two, when we look at this equation, we see that it's much easier to make the bases equal to each other than to make the exponents equal to each other. So let's make the bases equal to each other then. Let's turn 4 into 2 to the power 2 sine x times cos x. What is that equal to? That's equal to 32 in terms of 2. That's going to be 2 to the power 5 times 1 minus 2 sine squared x. All right. Perfect. Now that we have this, we can drop the exponents. Yes, we can drop the exponents. Let go of the bases. Right. When we drop the exponents, this is what we get. We get 2 sine x times cos x is equal to 5 times 1 minus 2 sine squared x. But what is this? What are we looking at here? Remember that this is basically the double angle of cos. And when we look at this, what is that? This is the double angle of sine 2x. Right, so we can rewrite these two as the double angle of cos and the double angle of sine. Let's do that. Sine 2x is equal to 5 times cos 2x. Right. What is our objective? What were we trying to find? We were trying to find the value of tan 2x. All right. So what can we do to find tan 2x from what we have here? We can divide throughout by cos 2x. Right. What happens to this side? These two cancel. We're only left with 5. And what happens to this? We remember that this becomes y. That's because tan of theta is equal to sine of theta over cos of theta. Yeah? So that's equal to 5. And that's your final answer. Cheers.